Today we're going to be looking at a coral reef. This coral reef has a volume of 1,200 cubic centimeters, and it's going to double each year. So those seem important, like important facts. You're going to write an equation. What type of equation is this?
Exponential.
Exponential. How do we know?
Multiply.
It's repeated multiplication, right? Repeated addition gives us what type of function? Linear. This is repeated multiplication. So you're going to write an equation for the situation. Then you're going to find the volumes for these values of t years. You're going to say, what does t to the negative 2 mean in context? And then you're going to give me a year where there was 37.5 cubic centimeters. Let's go. In your math notebook, yes. Bob's going to help me set up our function. So y equals what, Bob? Where'd you get that number? What? I mean, like in context, not in location, my man. What is 1,200? Of what? Clownfish? Of the coral, yeah, so 1,200 cubic centimeters, that's how much coral I'm starting with. Spencer, what's happening to my coral?
It's doubling each year.
It's doubling. How many times? Each year. So how do I represent like that each year in my t times? Boom. My function literally says I'm starting with 1,200, I'm doubling it each year. Whenever, I don't know if you've heard me say this before, but when we write a function, make sure you can summarize your context with your function, because your function is the context. It's just like you already translated it. So let's find the volume when we know that t is 5. What does t is 5 mean? I'm not going to do this every time for all of them, but that means it's going to double 5 times, right? So if I have 1,200 and I double it 5 times, carry the 6, okay, 38,400 cubic centimeters, correct?
Yep.
So that means 5 years we have that much. After 1 year, how much would there be?
2,400.
2,400 doubles once. 0 years.
1,200.
Yeah, that's my starting amount, right?
Yep.
Negative 1 years.
600.
So you did half as much instead of doubling, you did half?
Yeah.
And then negative 2 years.
300.
So what does it mean when t equals 2? Negative 2. Who can tell me in context, what does that mean, Elliot?
2 years before this, like 2 years before they got 1,200.
Yeah, I'm going to say the first measurement. 2 years before the first measurement. So that's the big new thing today. We have that negative exponent. It means 2 years before. If 2 is 2 years after, 1 is 1 year after, 0 is where it started. 1 year before has to be negative 1. Further proof that negative exponent does not mean negative. So it decreased because of our function, but do we still have a positive number?
Yes.
Yes. When did we get 37.5 though? That we have to keep going back. Get smaller and smaller. And I got, when t is negative 5, let's test it out. 1,200 times 2 to the negative 5. 1,200 times 2 to the negative. And really what this means is we're dividing by 2 5 times. Oh, that's not a negative 5. 37.5. So 5 years before first record. Or so 5 years previous to that is when it was 37.5. All right, so we've seen that negative exponent. It's like new, but we can use prior knowledge to kind of further what we know about exponential functions. So we're gonna you guys know how to solve mystery or what? You guys think you know how to solve mystery?
Ash's birthday card was like a murder mystery.
A murder mystery? Yeah.
Oh, I still haven't solved it yet.
And here's what's up. 3 of you are wearing monocles right now, which means probably can solve a mystery. Here's the mystery. This woman, a person, I think it says she somewhere. Why did I say woman? Oh, it says her. Okay, so this woman takes some medication, but she does not know how much medication she took.
Because she forgot last time medication.
So here's what's up. Well, no, here's what we know. Using the table, we know how much medication is in her blood when she takes a blood test. But when she takes the blood test, it is not when she takes the medication, right? You have to like get somewhere. A doctor has to say, yeah, you get a blood test, and you get a blood test. So you can see that there's gaps in our knowledge with our table. Okay? So you're going to form the function for our situation here. Like what's happening to this medication over time. 0 time is when what? Is it when she took it or when she got the blood test?
When she got the blood test.
It's when she got the blood test because we don't know how much she had when she took it. All we know is how much when she got the blood test. You're going to find amounts -1 and -3 and fill out the table. And then you're going to say what they mean in context. Just the front page of the notes I'm about to hand out. So we're just going to look at the front page right now. We got this blood test. It happened right here. Okay? So, Stella, you're going to help me build the function. How much medicine are we starting with? 100. And what's happening to it? Yep. Half. And then how many times? T times. Does everybody see our function here as our context? And then just be mindful of it. This means the time of the blood test. This is not the time that the medication was taken because I do not have that information. So let's go down to B. 1 hour before the blood test, or -1 hours, right? How much must have been in the bloodstream then? 200. 2 hours before must have been what?
400.
Which means 3 hours before had to be
800.
800. So now you need to know what the medication is to know if dosage is crazy or not, right? So that seems like way high, but different medications have different like concentrations and dosages. So we filled out the table. In context, who can tell me what T = 0 means? Finn?
The hours after the blood test.
Hours after blood test. So if it's 0 hours after the blood test, that means when the blood test happened, right? And who can tell me what -3 means now in context? This is the new one. Eliana?
It's 3 hours before the blood test.
3 hours before the blood test, yes. And now we know that 3 hours before the blood test, 800 milligrams would be in the body. Okay, your job next. On the back side of your notes is to answer questions 3, 4, 5. Right here, I'm going to rewrite our function in case anybody needs it. But are you guys seeing like this is the base function for everything we've been doing? Yeah. Initial value, growth or decay rate, exponent as a variable. All right, finish out the back page, please. Okay, 3, 2, 1. Eyes up here, mouths closed. So when time is -5 or 5 hours before, I'm going to do 100 times 1/2 to the -5, and we get 3,200 milligrams. All right? So plot the points whose coordinates are shown on the table. I now have a -5, 3,200. I'm going to go with up here. What was -3 again? I can't flip back as easy as you.
Oh, -3.
800.
800, okay. -2 then was 400. -1 was 200. 0 was 100. 1 was 50. 25, and so on. So it looks like this. Okay. So using this graph of ours, when was there 500 milligrams? Micah?
2 hours and 15 minutes.
Yeah, so you can go right here. Somewhere between 2 and 3 hours. That's what I wrote. I used the table. Did you calculate out like, okay. Or I used the graph. Did you use the table? So I said between 2 and 3 hours before the blood test. That's our reference point, right? The blood test. When is there no medicine? Never.
That's what it does.
Half of half, there's something. Half of the half, there's still something. Half of something, it is always something. Now, I don't know what happens when you get down to the molecule on this eventually or something, but yeah.
Eventually there will be no.
Yeah, but if you're losing half, it gets really small really quick, right? So the stuff that you took before is like almost gone all the time. Yeah, kind of crazy to think about, right? In theory, never zero. But at some point, it's unmeasurable, right? Because like you go to decimal places like thousands, 10 of thousands, 100. At some point, it's non-measurable. They go. Some things can measure parts per million, but I don't know about medications if they go there. So we are now going to move to our lesson summary. When this is done, you're going to come and get the surprise from me. It needs to be quiet in here today. And when you're done with the surprise and give that to me, homework's in the top basket.